Hi there, I'm Chris Saxon, the SQL Wizard, and today we're going to take a look at some performance black magic. We've got the mystery of the vanishing 1 second waits. Let's get started. I have here two tables, my boring table and my magic table. Now at first glance, these appear the same. They've got the same columns in them, and if we look, they've got the same data in them. However, the magic table is special. It can reduce query execution time down to 0. To prove that, I've got this little 1 second wait function, which every time it's executed, just waits a second. We have 3 rows in our boring table, so when we execute it calling the function, it'll take 3 seconds to execute the query, as shown. And we can also see in a PL SQL block, if we call the 1 second wait function, it still takes 3 seconds to execute. However, when we call it from a magic table, we'll see instantaneous query execution time. Ready and bang! Instantaneous query execution. Nice. To prove it's still the same function, if we go back to our boring table, we see that it still takes 3 seconds to execute. We had here a query which should have taken 3 seconds to execute, but instead it was instantaneous. How did I do it? Let's take a look behind the curtain and see how it's done. Here's the script I used to set up this demo. I've got my 2 create table statements down here, and these are identical except for the table names. However, after creating the tables, I then altered the magic table, setting the result cache mode equal to false. Result cache, what's that all about? Well, this is a memory area that Oracle uses to store the output of queries. If you've got the result cache enabled on a table, instead of actually executing the query, it can look in result cache and get the result out of there, enabling instantaneous execution times. This looks awesome. If all we need to do to get instantaneous query execution times is enable the query result cache, why don't we just switch it on all the tables? Unfortunately, it's not that straightforward, and there's some catches to it. Let's take a more detailed look. The first issue is you must actually populate the cache, and you do this by fully executing the query. This means the first time you issue a query against the result cache table, it will take the normal amount of time to execute. And then subsequent executions are instantaneous. So for my demo here, it means I had to populate the cache by running the query first time round. And it doesn't stop there. These 2 queries appear identical. The only difference is we've got a table alias here. Now we can see that my first query executes instantaneously. However, this tiny change in the second query means that Oracle must fully execute it to populate the cache for this query. So even tiny differences in queries invalidate the ability of Oracle to use the cache. However, once we've populated it, we can see that, bang, we're back to instantaneous execution times again. The next issue arises when we modify data in the query result cache tables. If we delete a row from the table here and commit it, when we issue these queries again, we see that they take a few seconds to execute. Just deleting that row has invalidated the cache, meaning we need to fully execute the query again. However, having done so, bang, we're back to instantaneous execution again. We can see that caching whole tables isn't really a good idea. Not only is each individual query cached separately, but whenever you modify the underlying data, you have to re-execute the whole query again, losing instantaneous execution. Fortunately, there are some other ways you can use the query result cache. We can enable the result cache at the statement level using this result cache hint. So we put this in with our boring table and we can see that bang, we got instantaneous query execution. To prove it's down to the hint, let's query it again without it. We can see it takes 3 seconds to execute the query again. Going back to our hint and bang, instantaneous execution. We can also set result caching at the session level using this alter session statement, setting it to false. If we do that, all statements within the session from now on are candidates for caching. So we issue our boring table query again, bang, it's instantaneous. However, if we set the result cache mode back to manual, like so, we'll see the query takes 3 seconds to execute again. Given all these limitations, you may be saying to yourself, what's the query result cache good for? Seems to have too many restrictions. Well, there are a couple of use cases that it is good for. Let's take a look. The first example is reference information, things like countries and currencies. These are typically small tables with data that doesn't change very often. However, they can be heavily queried, for example, to fetch the current exchange rate. By enabling these tables with the result cache, you can reduce the load on your database for these heavily executed queries. The second example is BI dashboards. These can often contain many queries which are executed against your database every couple of minutes or so. However, the output of these statements won't always change every 2 minutes. For example, yesterday's sales only changes once a day. By using the query result cache on these infrequently changing queries, you can reduce load on your database and get faster refresh times for your dashboard. That was the query result cache. We've seen we can enable it at the table level, which will cache all the queries against a given table, which probably isn't that useful. At the session level, which will cache all the queries within a given session, which is only really useful if you're going to reissue the same query multiple times within that session. And finally, probably the most useful situation is at the statement level, using a hint. In all these circumstances, the query result cache is most effective when the number of times you're going to execute a given query is significantly greater than the number of times you're going to modify the underlying data. I'm Chris Saxon, the SQL Wizard. Thanks for watching. Thanks for watching. I'm Chris Saxon, the SQL Wizard. Subscribe to my YouTube channel to get future updates on more SQL magic. I'll see you next time.